atom has 5, 6, or 7 electrons, it will gain electrons. So if it has 3, 2, or 1, it will lose them because it's so far away from getting 8. 3 or less. But if it has 5 or more, then it will gain 5, 6, or 7. Good question. 4 is right in the middle. We'll talk about 4 later. Okay? So we'll only deal with 3, 2, 1, 4, 5, 6, 7. So what happens is this atom, what used to be an atom right here, is now going to give away an electron. So what I do is I circle that electron and I draw a little squiggly line leaving. Don't do that yet. Just watch. Just watch. Now, as soon as that electron leaves, that means there's no electron there. Electron is gone. That means this last energy level is empty. If the energy level is empty, it just goes away. There's no energy level unless there's electrons in it. So I get to erase that last energy level. And now what you notice is on the outside it now has how many electrons? 8. It's got its magic number of 8. But this has 11 protons, but now it only has, careful, not 8, 8 on the outside, plus 2 more, 10 electrons. So now it is not neutral anymore. Now, who's winning, the protons or the electrons? So it's got a 1 plus charge. I can't call this a sodium atom anymore because it doesn't have the same number of protons and the same number of electrons. I have to call it a sodium ion. An ion is a metal atom that has lost electrons. So what I would like you to do is for letter C on question number 1, it says, does it make more sense for sodium? Now we're back on P12. We slid back to P12 because we're talking about sodium. Does it make more sense for sodium to gain or lose electrons? And it would say lose. It makes more sense for him to lose. And then it says for letter D, how many electrons does it make sense for sodium to lose? It makes sense for him to lose 1. 1. Then, for question number 2, it asks, please draw an atom of sodium that has lost its electron. Draw a picture of a sodium atom that has lost its electron or has turned into what we are calling today an ion. An atom that has either lost or gained electrons. And in this case, it has lost electrons. So we would draw this right here, showing those 8 electrons in energy level number 2. No longer is it an atom, it now is turned into an ion by losing an electron. 1 electron in this case. Once we draw this, we can now look at question 2, letter A, that says, how many protons does the sodium ion have? There are still 11 protons for the sodium ion. What I want you to notice, the whole point of this question is, the inside of the atom is protected. Nothing's happening to the inside of the atom. It's only the outside of the atom that changes. So there are still 11 protons, just like what it started with, 11 protons. Letter B says, how many electrons does the sodium ion have? It now has 8 on the outside, plus the 2 more in energy level number 1. So now there are 10 electrons. 10 electrons. And then finally, what is the overall charge? What's the overall charge? There is a 1 plus charge. 1 plus. All right. Just 1 plus. Just 1 plus. Plus. Good question. If I were to write 1p plus, I would be indicating a number 1 proton. But there's 1 more proton than there are electrons, so overall the charge is a 1 plus.
Well, 1 plus charge. And it knows an electron will be a 1 negative. That's what we talked about next. Good question.
Now, slide to the nonmetal, which is oxygen. So we're looking at T13 now, oxygen. All about oxygen. Now, because it's got 6 electrons on the outside, it's fairly close to getting 8 electrons on the outside. So it would make sense that it's not going to lose all 6, but it would gain, because it's close to getting that 8. And because it wants 8, it would gain 2 electrons. So we're going to redraw this, except what we're going to do when we redraw it is I'm going to add in an electron here. I'm going to add in an electron here, and then I'm going to put a little squiggly line or arrow indicating those are the 2 added or extra electrons that it got. So we redraw this, and now I don't get to call it an oxygen atom anymore. It gained 2 electrons. Why did it gain 2 electrons? It gained 2 electrons so that on the outside it would have 8. All the atoms want 8 on the outside. It had 6. How did I know it had 6? Because it's in column 6A. So, because it has 6 already, it wants to get 2 more, so it'll have 8 on the outside. Yes?
Is the magic number always going to be 8?
Magic number is always going to be 8. Good question. Except when you're dealing with energy level number 1. Energy level number 1, the magic number is 2. Because it can only hold 2 electrons. But all the other ones will be 8. Good question. So now, I got to call it something different. I can't call it an oxygen atom anymore. I have to call it something different. Now, here, it's an ion because it gained electrons. An ion is an atom that either loses electrons or gains electrons. But here's the difference. Sodium keeps its first name and only changes the end. So instead of calling it a sodium atom, I call it an sodium ion. Instead of a sodium atom, a sodium ion. Now, here's what oxygen does. Anytime you're gaining electrons, instead of calling it oxygen, we call it oxide. Oxide. We call it the oxide ion. The oxide ion. So the ones that gain electrons, we will change their name. And we'll be learning how to write their name. But the ones that are losing electrons, all you do is instead of calling it an atom, you call it an ion. So the same name, but you just change it from ion to atom. Alright, and then finally, the last part of this, I have to change the number of electrons. The number of protons stayed the same, but now, instead of having 8 electrons on the outside, it's got 2 in energy level number 1, it's got 8 in energy level number 2, and so now it's got a total of 10 electrons. Yes, these squiggly lines point to the new electrons. Good question. Squiggly lines are pointing to the added or extra electrons. I would, just to show it that they've added in. I think that's a good point. So now I ask myself, who's winning, the positives or the negatives? The negatives, the electrons are winning. But this time, be careful. Over here, the protons were winning by 1, so it was a 1 plus. Over here, the electrons are winning by 2, so we would say it's a 2 negative. 2 negative. Here's the hardest thing for students to understand, in my experience. Here, you were losing an electron and you became positive. Here, you were gaining electrons and you became negative. In our minds, typically, losing is a negative thing and gaining is a positive thing. But what you're losing negative electrons. So when you're losing, you become positive. When you are gaining, you become negative. One way you can think of this is giving is a positive thing to do. It's a good thing to do. So giving, you become, the atom or ion becomes positive. And then receiving